In the Beginning Flipbook, available at creationsciencecenter.org, page 209, Fossils. When liquefaction lenses slowly collapsed for the last time, the plants and animals were trapped, flattened, and preserved between the lens roof and floor. Fossils sandwiched between thin layers were often spread over a wide surface, which geologists call a horizon. Thousands of years later, these horizons gave some investigators the false impression that those animals and plants died long after the layers below were deposited and long before layers above were deposited. A layer with many fossils covering a vast area was misinterpreted as an extinction event or a boundary between geological periods. Early geologists noticed that similar fossils were often in two closely spaced horizontal layers. It seemed obvious that the subtle differences between each layer's fossils must have developed during the assumed long time interval between the deposition of each layer. Different species names were given to these organisms, although nothing was known about their inability to interbreed, the true criteria for identifying species. Later in 1859, Charles Darwin claimed that a previously recognized mechanism, natural selection, accounted for the evolution of those subtle differences. However, if liquefaction simply sorted organisms based on their already existing natural variations, Darwin's explanation is irrelevant. Two faulty principles. Early geologists learned that fossils found above or below another type of fossil in one location were almost always in the same relative position, even many miles away. This led to a belief that the lower organisms lived, died, and were buried before the upper organisms. Much time supposedly elapsed between the two burials because sediments, at least today, are usually deposited very slowly. Each horizon became associated with a specific time, perhaps millions of years earlier or later than the horizon above or below. Finding so many examples of the proper sequence convinced early geologists they had found a new principle of interpretation, which they soon called the principle of superposition. Evolutionary geology is built upon this and one other principle, the principle of uniformitarianism, which states that all geological features can be explained by today's processes acting at present rates. For example, today river deposit sediments at river deltas. For example, today rivers deposit sediments at river deltas. Over millions of years, thick layers of sediments would accumulate. This might explain the sedimentary rocks we see now. After considering liquefaction, the flaws in both principles become obvious. Sediments were sorted and deposited throughout a tall liquefaction column almost simultaneously by a large-scale process not occurring today. These principles are really called assumptions. Calling them principles gives them undeserved credibility. Testing the theories. Testing the theories. How can we compare and test the two conflicting explanations, liquefaction versus uniformitarianism, and the principle of superposition over billions of years? Number one, sedimentary layers often span hundreds of thousands of square miles. River deltas, where sediment thickness grows most rapidly today, are a tiny fraction of that area. Liquefaction during a global flood would account for the vast expanse of those thick layers. Current processes and eons of time do not. Number two, one thick, extensive sedimentary layer has remarkable purity. The St. Peter sandstone, spanning about 300,000 square miles in central United States, is composed of almost pure quartz, similar to sand on a white beach. It is hard to imagine how any geological process other than global liquefaction could achieve this degree of purity over such a wide area. Most processes involve mixing, which destroys purity. Number three, today's sediments are usually deposited in and by rivers along a narrow line. However, individual sedimentary rock layers are spread over large geographical areas, not on long, narrow, stream-like paths. Liquefaction during the flood acted on all sediments and sorted them over wide areas in weeks or months. Number 4, sedimentary layers are usually thin, sharply defined, parallel, and horizontal. They are often stacked vertically for thousands of feet. If layers had been laid down thousands of years apart, surface erosion would have destroyed this parallelism. Liquefaction, especially liquefaction lenses, explain these sharp boundaries. Number 5, sometimes adjacent parallel layers contain such different fossils that evolutionists conclude that those layers were deposited millions of years apart, but the lack of erosion shows that the layers were deposited rapidly. Liquefaction resolves this paradox. Number 6, many communities around the world get their water from deep, permeable, water-filled sedimentary layers called aquifers. When water drains from an aquifer, the layer collapses, unable to support the overlaying rock layers. Collapsed aquifers cannot be replenished. So how were aquifers originally filled? Almost all sorted sediments were deposited within water, so aquifers contained water when they first formed. Today, aquifers are collapsing at an alarming rate globally, so they could not have formed millions of years ago. Instead, liquefaction sorted sediments and created aquifers relatively recently during the flood. Number 7, varves are extremely thin layers, typically 0.004 inch or 0.1 millimeter, or 1/10 of a millimeter, which evolutionists claimed are laid down annually in lakes. By counting varves, evolutionists believe that time can be measured. The Green River Formation of Wyoming, Colorado, and Utah, a classic varve region, contains billions of flattened, paper-thin, fossilized fish. Thousands were buried and fossilized in the act of swallowing other fish. See Figure 10 on page 18. Obviously, burial was sudden. Fish lying at the bottom of a lake for years would decay or disintegrate long before enough varves could bury them. Besides, dead fish typically float, deteriorate, and then sink. Most fish fossilized in varves show exquisite detail and are pressed to the thinness of a piece of paper, as if they had been compressed in a collapsing liquefaction lens. Also, varves are too uniform, show almost no erosion, and are deposited over wider areas than where streams enter lakes, where most lake deposits occur. Liquefaction best explains these varves. Prediction 14. Coring taking anywhere in the bottom of any large lake will not show lamentations as thin, parallel, and extensive as the varves in the 42,000 square mile Green River Formation, probably the world's best known varve region. Number 8. In almost all cases, dead animals and plants quickly decay, are eaten, or are destroyed by the elements. Preservation as fossils requires rapid burial in sediments thick enough to preserve body forms. This rarely happens today. When it does, as in an avalanche or a volcanic eruption, the blanketing layers are not uniform in thickness, do not span tens of thousands of square miles, and rarely are water deposited. Water is needed if cementing is to occur. Liquefaction provides a mechanism for rapid but gentle burial and preservation of trillions of delicate fossils in water-saturated sedimentary layers. See also rapid burial on page 19. Thousands of fossilized jellyfish have been found in central Wisconsin, sorted to some degree by size into at least 7 layers spanning 10 vertical feet of coarse-grained sediments. Evolutionists admit that a fossilized jellyfish is exceedingly rare, so finding thousands of them in what was coarse, abrasive sand is almost unbelievable. Claiming that it occurred during storms at the same location on 7 different occasions, but over millions of years, is ridiculous. What happened? Multiple liquefaction lenses vertically aligned during the last liquefaction cycle trapped delicate animals such as jellyfish and preserved them as the roof of each lens gently settled to its floor. Number 9. Fossilized footprints, worm burrows, ripple marks, and imprints of raindrops would have been made during the early weeks of the flood in sediments lifted above the floodwaters by fluttering crust. Minutes later, the crust submerged and new sediments gently buried these delicate imprints that are now called trace fossils. Today, without rapid burial and a source of gentle blanketing sediment mixed with cementing agents, trace fossils cannot be preserved. Okay, direction of movement to the side, general direction of toes to the top. Figure 107. Drifting footprints. Hundreds of footprints along 44 different trackways were discovered in cross-bedded sandstones of northern Arizona. Surprisingly, movement was in one direction, but the toes pointed in another direction, sometimes almost at right angles. This shows that the animals, probably amphibians, encountered some type of lateral flow while walking on sand. It also contradicts the standard story that cross-bedded sandstone layers were once ancient sand dunes. Almost all trackways moved uphill, and traces of the animals' bodies are never found, even as fossils. Obviously, thick sediments must have gently and quickly blanketed the footprints to prevent their erosion. But how? Evolutionists have difficulty explaining what protected those delicate footprints. How did it happen? During the early weeks of the flood, flutter amplitudes were large enough for the crust to rise repeatedly, but slowly out of the floodwaters. Frightened animals and sometimes dinosaurs scampered uphill onto the rising land, each leaving footprints. Minutes later, the crust again submerged, allowing sediments falling through the thick, muddy waters to blanket and protect the prints while the rising water swept the animals' bodies away. Other perishable prints called trace fossils were made in the same way. Each time the fluttering crust rose above the muddy waters, it had, in evolutionary terms, thousands of years worth of additional layers, sediments containing sorted dead things trapped in liquefaction lenses. The approximate order of burial from the bottom up was sea bottom creatures, then animals and plants that were first overcome, ripped up and deposited by the initial floodwaters, followed by larger animals that could float and live for a time, such as many dinosaurs, and finally mobile animals that could flee to high ground. Each region had its own mix of plants and animals. Once they were buried in sediments, liquefaction provided additional sorting by such characteristics as density and shape. Sometimes dinosaur prints from the previous upward flutter minutes earlier were sandwiched between layers that never experienced liquefaction again. 10. Many fossilized fish are flattened between extremely thin sedimentary layers. This requires squeezing the fish into the thinness of a sheet of paper without damaging the thin sedimentary layers directly above and below. How could this happen? Because dead fish usually float. Something must have pressed the fish onto the seafloor. Even if tons of sediments were dumped through the water and on top of the fish, thin layers would not lie above and below the fish. Besides, it would take many thin layers, not one, to complete the burial. We do not see this happening today. However, liquefaction would sort sediments into thousands of thin layers during each wave cycle. Liquefaction lenses would simultaneously form at various depths in the sedimentary column. Fish that floated up in the water lens would soon be flattened when the lens finally drained. Number 11. Sediments such as sand and clay are produced by eroding crystalline rock, including granite and basalt. Sedimentary rocks are cemented sediments. On the continents, they average more than a mile in thickness. Today, two-thirds of continental surface rocks are sedimentary. One-third is crystalline. If the sediments we see today, including sedimentary rock, were produced by eroding crystalline rock at Earth's surface, the first blanket of eroded sediments would prevent the crystalline rock below from producing additional sediments. As more sediments are produced and deposited, fewer sediments could be produced. Exposed crystalline rock would disappear long before all today's sediments and sedimentary rocks could form. Transporting those new sediments, often great distances, is another difficulty. Clearly, most sediments did not come from the Earth's surface. They must have come from powerful subsurface erosion, as explained by the hydroplate theory, when high-velocity waters escaped from the subterranean chamber. Number 12. Some limestone layers are hundreds of feet thick. The standard geological explanation is that regions with these deposits were covered by incredibly limey, alkaline water for millions of years, a toxic condition not found anywhere on Earth today. Liquefaction, on the other hand, would have quickly sorted limestone particles into vast sheets. See the origin of limestone on page 267. Number 13. Conventional geology claims that coal layers, sometimes more than 100 feet thick, formed from 1,000-foot thick layers of undecayed vegetation. Nowhere do we see that happening today. However, liquefaction would have quickly gathered vegetation buried during the early stages of the flood into thick layers, which would become coal after the confined oxygen-free heating of the compression event. Number 14. Coal layers usually lie above and below cyclothems, see page 209, which sometimes extend over 100,000 square miles. If coal accumulated in peat bogs over millions of years, the standard explanation, why don't we see such vast swamps today? Why would a peat bog form a coal layer that was later buried by layers of sandstone, shale, limestone, and clay, generally in that ascending order? Why would this sequence be found worldwide and sometimes be repeated vertically 50 times or more? To deposit a different sedimentary layer would require changes in environment and elevation, and of course, millions of years. But liquefaction provides a simple, complete explanation. Number 15. Fossils are sorted vertically to some degree. Evolutionists attribute this to macroevolution. No known mechanism will cause macroevolution, and many evidences refute macroevolution. See pages 13 to 33. Liquefaction, an understood mechanism, would tend to sort animals and plants. If liquefaction occurred, one would expect some exceptions to this sorting order. But if macroevolution happened, no exception to the evolutionary order should be found. Many exceptions exist. See out-of-sequence fossils on page 21. 16. Animals are directly or indirectly dependent on plant or food. However, geological formations frequently contain fossil animals without fossilized plants. How could the animals have survived? Evidently, liquefaction sorted and separated these animals and plants before fossilization occurred. 17. Meteorites are rarely found in deep sedimentary rock. See shallow meteorites. This is consistent only with rapidly deposited sediments. The mining industry rediscovers liquefaction. The mining industry frequently uses a technique called jigging to extract valuable minerals from ores, sediments, or crushed rock. Jigging will remind you of liquefaction during the global flood, except that during the flood, the sorting forces were thousands of times greater, and they acted on thousands of feet of sediment over the entire Earth by wave loading. With jigging, cyclic water pulses in massive machines to briefly lift sedimentary particles. The particles then settle and increasingly stratified by density and size. Videos of jig machines in action can be found by searching jig machine separation. Liquefaction and fossils. From In the Beginning by Dr. Walt Brown, available at creationsciencecenter.org.